AP Physics 1, question 1. Okay, so here we have two blocks that are connected by a string that runs over massless pulleys. Now the fact that these pulleys are massless is important. So what that means, if it's a massless pulley, it means like it's basically not even there. It takes no force at all to get that pulley to accelerate. So the significance of a massless pulley is that the tension on each side, so there's a tension pulling on that pulley this way, and then there's a tension pulling on the pulley that way. Those tensions are equal. And then same thing for this pulley over here. There's a tension this way, and there's a tension pulling that way. All these tensions are equal. The pulley is completely massless. Okay, so the first thing we're going to do is we're going to do free body diagrams for each block where these dots represent the blocks. And we have to pay attention to the relative lengths of the vectors that we draw that represent the forces. So the thing to realize is that block 2 has a greater mass than block 1. So the acceleration of this system, and when I say system, I mean all of this together. It's M1 and M2 is our system. The acceleration is going to be this way, right? M1 is going to accelerate. M1 is going to accelerate up, and then the acceleration continues like that, and then M2 is going to accelerate down. Now, if the acceleration is that way, so let's revert this back. So if block 2 accelerates downward and block 1 accelerates upward, what that means is that, so let's focus on M1. So in order for mass 1 to accelerate upward, the upward force must be greater than the downward force. So looking at M1, there's going to be a tension up and then force of gravity down. So actually, let's make tension a little bigger. So tension is going to be like that, an upward tension, and then force of gravity, and I'm purposely drawing that smaller. Force of gravity is weight, which is mg, so we'll label that m1g. So for M1 to accelerate upward, the upward force of tension must be greater than the downward force of gravity. So let's draw that over here on our free body diagram. So we're going to show, let's draw this upward 3 grid lines up. So we went 1, 2, 3, and we're going to label that T for tension. Now, in order for block 1 to have that upward acceleration, it must be bigger than the downward force of gravity. So I'm only going to draw that 2. So we'll label that M1G, which is the equation for force of gravity. So the key thing here is that the upward tension is greater than the downward force of gravity, which would allow for a upward acceleration, which is what we know block 1 is going to do. Now, for block 2, in a similar way, we know the acceleration is going to be down, so the two forces on block 2 are tension and gravity. Now, gravity is going to have to be bigger, so that's going to be m2g. In order for block 2 to have a downward acceleration, the downward force of gravity must be greater than the upward force of tension. Now, as we said earlier, if these pulleys are massless, it means like they're basically not even there. It takes nothing to get those pulleys to have an angular acceleration. And if that's the case, the tension in this string, the tension everywhere in the string is the same. So the tension on mass 1 and the tension on mass 2 have to be equal in length. So we drew this tension as 3 upward, right? 1, 2, 3. So we're going to draw this tension the exact same length. So what this shows is that tension is the same. Now we need block 2 to accelerate downward, so we need to draw our downward force of gravity greater than the upward tension. So let's do this 4. 1, 2, 3, 4, something like that. And we'll label that M2G. And that would give a downward acceleration for M2 and an upward acceleration for M1. Okay, and then again, just to realize about this massless, coming back to this massless pulley, if this were a torque question, which it's not, but if it were a torque question, in order to get this pulley to accelerate, so this pulley would be accelerating clockwise. The acceleration, let me see here. I don't want to revert this, but here I'll just draw it over here. So here's the pulley, and then we got M2 right here, right? There's tension up, and then a larger M2G down. Now here's the pulley right there. If this had been a torque problem and this pulley had not been massless, in order to get this pulley to accelerate, we would have a tension on this side. So now we would have to specify the tensions. We'd call this like T1, and then therefore on M2 this would also be T1, right? Because those are the same. It's the same piece of rope there. And then on this side we would have tension 2, and then these two tensions would not be the same if the pulley had mass and therefore rotational inertia. But for this problem, it's a massless pulley. Okay, so let's erase this. Okay, second question. So we're going to derive the magnitude, meaning size, of the acceleration of block 2, and we're expressing our answers in terms of these variables. Now, the acceleration of block 2, it's the same as the acceleration for block 1 because these guys are connected by a string. So, you know, block 2 and block 1 have the same acceleration. So basically, what we're really solving for here is the acceleration of the system. So the way we're going to do this is by summing our forces. So let's consider block number 1 first. So block number 1, we're going to sum the forces, paying attention to sign conventions. So for block 1, let's make the direction of the acceleration positive. So we're going to say up is plus and down is minus. So our summing of forces will be T minus M1G. Sum of the forces always equals MA. So that'll equal M1A. Now we're going to look at block number 2. We're going to do the same thing. We're going to sum forces. Now for block number 2, the acceleration is downward. So we're going to say down is plus, up is minus. We want the acceleration to be positive on both sides. So this is going to be M2G minus T equals M2A. We made the accelerations positive, so that's nice. We don't have to, we don't have to make acceleration negative because in both situations we said acceleration was positive. So now what we're going to do is we're going to combine these two equations. And I think the easiest way to do this is let's just add these two equations together, which does not violate any rules of algebra. So adding these two equations, the tensions will cancel because we have positive T and minus T. And that's going to leave us with M2G minus M1G equals M1A plus M2A. Simplifying this out, we're going to get G M2 minus M1 equals A M1 plus M2. So the acceleration comes out to be G M2 minus M1 divided by M1 plus M2. And this is the answer to the question. All right, the third part. Let's see here. So we're going to hide this. Okay, so the third question here. So now they add a third block. And again, the pulleys are massless. However, the tension is not going. The tension in this rope and the tension in that rope are no longer the same, and the reason why is because if you look at block number 3, which way is block number 3 going to accelerate? Well, if there's no friction between block 3 and the table, it says here, no friction between block 3 and the table, block 3 is going to move. Okay, now which way is block 3 going to move? In fact, it's going to accelerate to the right. Block 3 will accelerate to the right, which means we have a tension pulling block 3 to the right. Let's call that T1. And we have a tension pulling block 3 to the left. Let's call that T2. So if it's a massless pulley, then we're going to have T1 over here as well, acting on block number 2. And massless pulley, that means we're going to have T2 on this side as well. So the tension is no longer the same throughout the string because we have this third object here that needs to accelerate, and for block number 3 to accelerate to the right, T1 must be greater than T2. Okay, so the question is, will, what's the question? Indicate whether the magnitude of the acceleration of block 2 is now larger, smaller, or the same as it was in the original system. Okay, so focusing on block number 2, so here's M2. M2G did not change. So this is M2G, and then this tension here is smaller. Now, the tension acting on block number 2 must be greater than what it was in the first situation. And the reason I know that is because in order for block number 3 to accelerate to the right, this tension must be greater than that tension. So we have a greater tension and a smaller tension. So the tension acting on block 2 is now greater than it was in the original situation. And if this tension is greater, the downward acceleration of M2 must be smaller. All right, so let's just go take a look at what the actual College Board answers are and make sure we hit everything. So here's the answer key. So for the first question, 1 point was awarded for drawing 2 vectors starting on the dots that point upward and have the same length. So we talked about that. These tensions must be the same length. The second point was for drawing 2 vectors starting on the dots pointing downward, where the vector for block 1 is smaller than the vector for block 2. Okay. Here is their solution for part B, which is where we're solving for the acceleration. So basically we're summing forces. You got to sum forces for block 1, you get a point. Sum forces for block 2, you get a point. And then combining the 2 equations to eliminate T. For the third question, so the acceleration will be smaller. So the first point is for indicating the mass of the system is larger, and then for mentioning that the tension on block 2 is greater. So I think we hit all those.